For question 1b, it is asking us to estimate the intercept using OLS. In this case, b1 would equal to y bar minus b2 times x bar. B1 would equal to 7 minus 5 halves times 3, or 7 minus 7.5, which would equal to minus 1 half. For question 1c here, it is asking us to find the sum of squared residuals. The sum of squared residuals is yi and y hat squared, not xi minus x bar squared. To find y hat for all of the values of 4, 2, and 3, we just plug it into the equation here to get 9.5, 4.5, and 7 respectively. And for each value of yi is 9, 4, and 8. When we plug it into the equation and do the algebra, we get 9 minus 9.5 squared plus 4 minus 4.5 squared plus 8 minus 7 squared, which would equal to 0.25 plus 0.25 plus 1, which would equal to 1.5. For question 1d, it is asking us, what is the standard error of regression in rounded 3 decimal places? The standard error of regression is you find it using the formula of the square root of 1 divided by 1 times the summation of yi minus y hat, quantity squared. 1 divided by 1 is 1 times minus 0.5 squared plus another minus 0.5 squared plus 1. The whole thing square root is equal to the square root of 1.5, or and when you plug into the calculator, you'll get 1.225. For question 1e, it is asking us, what is the r squared of the OLS regression rounded 3 decimal places? R squared is found by using the formula 1 minus the residual sum of squares divided by the total sum of squares. In this case, the residual is the summation of yi minus y hat squared, and then the total sum of squares is found by yi minus y bar squared. From the previous part, we found that the summation of yi minus y hat squared is equal to 1.5, except in that case we square rooted it. This one we don't. The answer for yi minus y bar squared is equal to 9 minus 7 squared plus 4 minus 7 squared plus 8 minus 7 squared, which is equal to 14. The top part is 1.5, the bottom part is 14. We take that divided by each other and then subtract from 1 to get 0.893. For question 2a, it is asking us, what are the necessary population assumptions required for the ordinary least squares estimator B2 to be an unbiased estimator for B2? In this case, we only need 2 here, which would be that yi is equal to beta 1 plus beta 2xi plus ui, and that e of ui given of xi is equal to 0. For 2b, it asks us what are the necessary population assumptions required for the ordinary least squares estimator B2 to be a consistent estimator for B2. That one, we only need the variance of ui given xi is equal to sigma squared of u, and that ui and uj are statistically independent. For question 2c here, it says, what does B2 equal to 1/2 mean in words? It means that a 1 unit increase in x of I is associated with a 1/2 increase in yi. For question 2d, it is asking us, now that we assume we are estimating the log of yi is equal to b1 plus b2 of xi plus e of I, what does B2 equal 1/2 mean in words? Since this is a log linear function, it means that a 1 unit increase in x of I is associated with a 50% increase in y. For 3a, it is asking us to give us the lower bound of the 95% confidence interval for the population intercept coefficient, rounded 3 decimal places if necessary. Here I would use the table, and the one that we are looking for is the population intercept coefficient. Population coefficient intercept would be the constant here, and now that we look at the lower bound of the confidence interval, it is actually 2267.5. For question 3D part 1, it is asking us what is the null and alternative hypothesis. Since we are using the information that someone claims that a 1-year increase in the average age of birth mothers is associated with an increase in average infant birth weight of less than 15 grams, perform a test at the 10% significance level using the p-value approach. Here, your alternative and null hypothesis is actually your null is equal to beta 2 is greater than or equal to 15, and your alternative hypothesis is anything less than 15. For question 3D part 3, what is the relevant p-value? Here I simply forgot a step here, but you are supposed to subtract this answer from 1. So it is supposed to be 1 minus the 0.43, which would equal to 0.57. For question 3E, it is asking us to predict the average birth weight in that state and round to 3 decimal places. Here, the average birth weight is equal to 2,775, which we found from the table here, plus 16.66 times 33, which would equal to 3,324.78. For question 4, part 1, it is asking us to provide a 95% confidence interval for the difference in mean birth weight between infants born to mothers who are non-smokers and infants born to mothers who are smokers, and we round all calculations and final answers to 3 decimal places. So the lower bound should be, to find the confidence interval first, we have to use the formula the mean of non-smokers minus the mean of smokers plus or minus the critical value times the standard error of the mean of non-smokers minus the mean of smokers. First thing we should find is the standard error. The standard error of that is using the formula of the square root of sigma squared over n of non-smokers plus sigma squared over n of smokers. We plug in the values 57.8 squared divided by 49 plus 69.4 divided by 36 squared, which would equal these numbers. You take the whole thing, you square root it, it should equal to 14.212. For the critical value, it is equal to t of 83, and the reason why it's 0.025 is because it's a two-tail test at the 5% significance level. So our critical value is 1.95. The whole 95% confidence interval is equal to 3,279 minus 3,060 plus or minus the critical value of 1.95 times the standard error of 14.212. You should get 219 plus or minus the 27.7134. For this first part, we're looking at the lower bound, so we subtract 27, and we should get 191.287. For part 2, it is the opposite. We're looking for the upper bound, so instead of subtracting here, we add 27. So we get 246.713. For question 4, part 3, it is asking us that someone claims that infants born to mothers who are non-smokers have an average birth weight of more than 200 grams, higher than infants born to mothers who are smokers, and we test this at the 5% significance level using the critical value approach. So for here, the null hypothesis, since this is a bivariate regression, we do the mean of non-smokers minus the mean of smokers, and it is actually less than or equal to 200. The alternative hypothesis is anything greater than, so it'd be the mean of non-smokers minus the mean of smokers is greater than 200. For question 3, it is asking us what is the relevant t statistic, round all calculations to 3 decimal places. So the t statistic here, you would have to use two variables, the mean of non-smokers and the mean of smokers, subtracted from minus 200 divided by the standard error of mean of non-smokers minus the mean of smokers. From previous, we found that the standard error is 14.212, and this part is 219. We take 219 minus 200 divided by 14.212, which would equal to 1.337. And for number 4, it is asking us what is the conclusion, and find all relevant critical values to find your conclusion. So here we found that t is actually 1.337, and our critical value is 83 at the 5% significance level. And since this is a one-tailed test, we keep the alpha level at 0.05. So our critical value would be 1.62. Normally, when you do one of these tests, when the absolute value of t is greater than c, we reject the null hypothesis. But in this case, the absolute value of t is 1.337. It's actually smaller than the critical value of 1.62. So in this case, I failed to reject the null hypothesis that is equal to the mean of non-smokers minus the mean of smokers is actually less than or equal to 200 at the 5% significance level, because we just have more evidence that says otherwise.